Okay, so in this video what I'm going to do is I'm going to go over the sarcomere. So in order for us to do that, we got to know where it comes from. It's the sarcomere is going to be within a myofibril, okay? And the myofibril is going to be within a muscle cell. So if we look at the muscle cell from the lowest magnification to the highest magnification, okay, so we'll look at this one here from the video we saw before. This is the muscle cell, okay? And inside this muscle cell, you have a bunch of myofibrils, little dots in here. Not these circles, but the dots within the circles. Okay, so let's look at the muscle cell a little bit bigger in this model. Okay. So here's a skeletal muscle cell. So one of those muscle cells that I showed you in the previous model is one of these. So this is one muscle cell, which is made up of these myofibrils. Okay. These myofibrils look like these spaghetti strands, like this. Okay. And finally we get to this even more magnified model. And this will be one myofibril. One giant myofibril. And this myofibril is going to be made up of a bunch of sarcomeres, which are the smallest contractile unit in our body. Okay. So here you see a sarcomere from this Z line to this Z line here. That's going to be a sarcomere. Okay. Alright, so let's see if we can do it a little bit more like this one to do on this side. Alright. But before we get into the sarcomere, let me point out some things that you'll find inside this muscle cell. Or here you have the sarcolemma, which is the cell membrane of the skeletal muscle cell. The liquid inside is going to be the sarcoplasm. Okay. You see these little red structures. All these red ones here, these are called mitochondria. Okay, mitochondria. Okay. This yellow webbing here, that's called Sarcoplasmic Reticulum, which produces the calcium. Okay. And you see a bunch of these little holes that the cell membrane folds into the cell. Those holes are going to lead to these cell membrane called Tubule. Okay, so the sarcolemma folds in and becomes T-tubules. So electricity is going to travel down the sarcolemma, then down the T-tubule. And as electricity goes down the T-tubule, it's going to cause the release of the calcium from the terminal cisterna. Okay, so there's two terminal cisterna, and this T-tubule is called a triad. So this is a triad right here. The T-tubule down the middle, two terminal cisterna. So when electricity comes down the sarcolemma, down the T-tubule, it causes the terminal cisternas on either side to release calcium. Then the calcium is going to go down here into the sarcomere and cause the contraction of the sarcomere. So let's look at the sarcomere. So the sarcomere, from Z line to Z line, it's a sarcomere. Okay, splitting it down the middle is an M line. All right. On either side of the M line, okay, on either side of the M line, you're going to have the H band. Okay. Now from the end of this myosin to the end of that myosin, that's going to be the A band. And this is going to be the I band. Now, you can pretty much draw a sarcomere if you need to. What you do is just draw a line down the middle for the M line, draw myosin strands going laterally on either side, then draw Z lines on the borders, and draw actin going towards the middle, never touching the M line on either side. By doing that, you can draw a sarcomere, then you can start labeling the bands, zones, and lines. Okay. So again, Z line to Z line is a sarcomere, splitting it down the middle is the M line. Either side of the M line, if you just intersect myosin, that's going to be the H band. From the end of this myosin to the end of that myosin, all that is A band. And this part here where you have overlapping of myosin and actin is called the zone of overlap. So the T-tubules are strategically placed right next to the zone of overlap because the calcium is going to go down to the zone of overlap and then start the process of contraction of the sarcomere. And then here you have the I band, which is just actin. If you intersect it, you're just going to intersect actin. Okay. And then from Z line to Z line is sarcomere. So that's pretty much the makeup of a sarcomere within a muscle cell. Okay. And remember, there's a bunch of sarcomeres that are neighboring each other on a myofibril, all contracting at once. Okay. Depends on the activity that you're doing. You have different number of motor units that will cause you to do more contraction of sarcomeres than others, but for the most part, nerve is going to go down to the muscle cell, electricity is going to go down the sarcolemma, down the T-tubule, causing the internal cisterna to release calcium, which is go to the zone of overlap, and there you have the cross-bridging occurring. Okay, so that's pretty much it on the sarcomeres, on the myofibrils. Hope that helps. That's pretty much it. Hope you like and subscribe, and see you on the next video. Bye.